Okay, hello. So today we're going to be learning about graphing, graphing a line, and one method that we're going to learn today is by using the slope-intercept form. The slope-intercept form looks like this. It looks like y is equal to mx plus b. Yesterday I was talking about slope being a characteristic, and it being a characteristic, you're able to tell what direction, if it rises to the right or rises to the left. Okay. Well, today we're going to learn a different characteristic. The new characteristic that we're going to learn today is your y-intercept. And this is defined by the variable b. Okay, so this is the y-intercept. And it means exactly what it says, y-intercept. It's where the line crosses the y-axis, okay? So the y-intercept is where the line crosses the y-axis. So therefore, this is a point on that line because it's going to be, the line's going to be, it's going to be a point on that y-axis. So we can describe it as the point of the line. And I'll show you how do we do that right now. On this side here, we already know what this means. This means slope. It's also, if it's positive, we've learned that it rises to the right. And if it's negative, it rises to the left. This is also learned as rise over run. So this is a model here to allow you to see the characteristics when you have an equation in slope-intercept form. Now you can use this as a tool to allow you to graph, and I'll show you how we do that. Okay. If we have a problem like y is equal to 3x minus 1. Well, comparing it to the slope-intercept form, we can see that our slope is 3. So our m value is equal to 3. Well, if we're going to graph it, let's interpret it as rise over run. So let me go ahead and convert it to a fraction. So 3 in a fraction is 3 over 1. Okay. Here on the right hand side, we have the b value, which is your y-intercept. So the y-intercept is -1. Well, yesterday I was also indicating to you all that whenever you know the slope is kind of like the generator or a generator. So if you know one point, we're able to generate points by using the slope. And this is the way we do that. First, locate the y-intercept on the y-axis. So therefore, it's going to be a point that's going to be at -1. So this line is going to cross at -1. Okay, we also need to think about the other characteristics. We know that the slope is positive, so what do we remember about the slope being positive? Or what do we have? We have this tool here, this model. This allows us to indicate quickly of what direction the line goes when the slope is positive. Okay, if you already have it memorized, then that's great. So we know that the line goes up to the right. So now what we want to do is we want to use that slope value, and we want to use it so it can generate other points. So we go up 1, 2, 3, and then we go 1 over. Notice that I did the rise over the run, okay? Well, the rise is a vertical movement, and the run is a horizontal movement. You can choose to go either up and then to the right, or we could have also gone down and to the left 1 unit. In any case, after that sequence, we want to tag a point because we've just generated a point using the slope. So let's try it again. 1, 2, 3, 1 over. Now we don't have to leave these markings. These are dotted lines just to show you how I went from one point to the other by the path of the slope. Okay, if I were to get points that are to the left, I would have to go 1, 2, 3, and then 1 unit to the left. Notice that I always start from a point when I'm generating. A common mistake is students start at the origin. No, you don't do that. Okay, so you always start at a point and you generate other points by using the slope. So now I can draw a line through here. And I'll do it in blue. And there's my line of the equation. And this line is the line of y is equal to 3x minus 1. Pretty simple, right? Okay, let's continue here. Let me get a new page in here.